Hello, everyone. Welcome back. We're still Math 210, and we left off with logs getting ready for financing. So let's go to the next one. So remember, well, actually, let's go back and do a little review. So enter the page, and we're going to need some properties. Some of the properties that we will be using are if we have a log AV. This will mean that we have log A plus log V. Also, likewise, we have log A over V, which is division. Then we have, okay, if we have log then we can send that exponent to the front, leaving with log A. Also, if I have, what would be another one? Oh, change of base. Log base B to the A is equal to, if you noticed, the first three do not have a base. So when you do not have a base and you have the word log, you assume that the base is, what would be good? 10. Now, we also have what is known as natural log, which is just log with a base E. And all properties are the same. And I will be presenting more properties as we go along. So with these ones, let's see if we can answer this next examples. Okay. So this one we have solve log base. Log x is equal to log x plus 3 minus log x minus 1. So remember, these are subtracting, right? So let's rewrite this into a division because we're going to be using this second property. So this becomes log x is equal to log x plus 3 over x minus 1. Now, if we go to the top theorem right there, it says that if I have a log a u is equal to log a v, then my answer is u equals v. So on this one, the important part is that they both have the same base, a. On this problem we're working for, we have the same base, which is 10. That means we can follow this and we have this problem as x equals x plus 3 over x minus 1. To solve this, we can use what is known as cross multiplication. So I'm going to add a 1 and literally cross multiply. So this becomes x minus 1 is equal to x plus 3. I'm going to distribute that x. So I have x squared minus x is equal to x plus 3. I'm going to send everything to the other side. So this becomes x squared minus 2x is equal to 3 minus 3. So I have x squared minus 2x minus 3 is equal to 0. And from here, we could either factor, use the quadratic equation, or anything we want. I think we can factor on this problem, so let's factor. And that's going to be x. They're subtracting, so plus, minus. How do I know they're subtracting? Because of this one's telling me that we subtract. This guy right there. So this is going to be 3 and 1. Let's check our work. This one becomes plus x. this one becomes negative 3x, which equals negative 2x, which is correct because that's that middle term. So we have that. Then we have x plus 1 times x minus 3 is equal to 0. Then we're going to use what it's known as the zero product principle. So zero product principle, which states if I have a multiplication of a times b is equal to 0, then a is equal to 0 or b is equal to 0. So following that same logic, I can say that x plus 1 is equal to 0, and x minus 3 is equal to 0, minus 1 minus 1. We cancel, so I have x is equal to negative 1, plus 3 to both sides. The 3's cancel, and I have x is equal to 3. And that's the answer for this one. Okay? Now, this one's a little bit different. This, I'm going to go for this problem right here. I have log base 5 of 2x minus 3 is equal to 2. I'm going to go exponential on this one. So I'm going to go start with my base, which is 5. Go to the 2, that makes it squared, and we have to return, so that's 2x minus 3. That's 25 equals 2x minus 3. Then, plus 3 to both sides. Whoops, sorry. The 3's cancel, so I have 2x is equal to 28 divided by 2. So x is equal to 14. This one's a little bit different. This one I have to add log base x1 to both sides, so I can have the bases in one side only. The logs on one side, sorry. So I have, let's separate this. I have log x minus 16 plus log x minus 1 is equal to 2. Again, these two guys are adding, so they can multiply based on this property, the first property we have right here. So therefore this becomes log, open a big one, x minus 16 times x minus 1 is equal to 2. If we distribute this, we get log x squared minus x minus 16x plus 16 is equal to 2. Now, we can go exponential on this one as well because we have a base of 10. So therefore, we start at the base, go across the equal sign, so that's squared. And then we have to return, which is x squared minus x minus 16x plus 16. This becomes, let's simplify this, x squared. Negative 1 minus 16 is negative 17x plus 16 is equal to 100. Now, I'm going to send the 100 to the other side to use the zero product principle again. So therefore, I have 16 minus 100 is x squared minus 17x minus 84 is equal to 0. Using the zero principle property again, let me add another sheet of paper. Going back, we're right here. Copy. Paste, so we're right there. For this, I'm going to use the quadratic equation since I use Since I used factoring on the previous one, let's use the quadratic equation. Just a reminder, the quadratic equation states that x is equal to negative b plus or minus b squared minus 4ac all over 2a. So let's decide what's our a, b, and c on this one. So a is equal to 1 because of this. B is equal to negative 17 because of this. And C is equal to negative 84 because of this. So let's fill in the blanks. So negative because that's what the equation has, or the formula has. Then we have negative 17 plus or minus negative 17 squared minus 4. A is 1, C is negative 84, all over 2 times 1. Now, if we pay attention to this, we will get a real solution, because a negative times a negative will give me a positive, and negative squared is also a positive. So everything inside the square root is a positive number. Therefore, we can simplify and solve this. So this becomes a negative times a negative is 17 plus or minus 17 squared is 289. A negative times a negative again is positive. 4 times 84 is 336 over 2. That's a horrible big number. So let's keep on simplifying. So now I have 17 plus or minus 289 plus 336 is 625 over 2. Let me see if we can simplify that. 625. So 17 plus or minus the square root of 625 is 25 over 2. So now I have that x is equal to 17 minus 25 over 2. And x is equal to 17 plus 25 over 2. So I have x is equal to 17 minus 25. It's going to give me negative 8 over 2, which equals negative 4. And 17 plus 25 equals 42 over 2, which is 21. So x is equal to negative 4 and 21. Okay, so now we have another theorem here. This theorem states that if it's an exponential form and the base of the exponents are the same, then we can ignore the bases and just play or simplify the exponents. Okay? So, well, you're going to tell me, well, how can we simplify that if they don't have the same base? Well, let's find out. I have 9x is equal to 27. 9, I can divide it by 3, which will give me a 3. I can divide it by 3 again, which gives me a 1. So the only thing I did was divide. This is what I did. 6 divided by 3 is 3. That, I brought it down. And then 3 divided by 3 is 1. Okay? So therefore, I can rewrite this as 3 because it's a base of 3. And how many 3's do we see here? 2. So that's 2x. Equals. Let's see if we can do the same thing with 27. 27, I can divide it by 3. That's a 9. 9, I can divide it by 3. That's a 3. And 3 divided by 3 is a 1. So 27 is just base 3 to the power of 3. Now, since we have the same base as the theorem states, that means I can ignore the bases and just continue with the exponents. So I have 2x is equal to 3. I can divide this by 2 on both sides. Then I have x is equal to 3/2. Okay? Now this I mentioned a minute ago. I can send this to the exponents to the front since I'm using logs. Let's use natural log. Now I have 3x is equal to 5. This I can rewrite as the natural log of 3x is equal to the natural log of 5. This, I can do this because I'm adding natural logs to both sides. Meaning I'm still maintaining a balance, so this is a valid move. So now I have, oh, by the way, also this, x can be sent to the front. So I have x times natural log of 3 is equal to the natural log of 5. Divide by the natural log of 3 to both sides. So I have that x is equal to the natural log of 5 over the natural log of 3. And to do that, that actually is a solution. But if you wanted to, we can approximate this to approximately 1.465. Okay, we're at example 5. Example 5 is a little bit more tricky. So let me rewrite that so we can see that a little bit better. 2x minus 1 is equal to 4x plus 2. Okay? We can't use the base trick we used a minute ago because exponential base because 3 is already prime. So we can't do that one. So what can we do? Well, we can include natural logs to see what we can do with all of this. So let's see what this happens, okay? So I'm going to do natural log of 3, 2x minus 1 is equal to natural log of 4x plus 2. Again, this is a valid move because I'm using the natural log to both sides, which allows me to maintain my balance still. So now I can send the exponents to the front. So I have 2x minus 1 times the natural log of 3 equals x plus 2 times the natural log of 4. Now, this is not going anywhere that much. So let's see what we can do to simplify this thing. Let's try distributing. Okay, so this will become 2x times natural log of 3 minus natural log of 3. Since 1 times any number, it's itself, that number is equal to x times, where is it? Natural log of 4 plus 2 natural log of 4. Now I'm going to put all the variables in one side and the coefficients in the other. So that means I'm going to add plus. This will cancel this. So I have 2x times natural log of 3 is equal to x times natural log of 4. Actually, let's rewrite that because that's going to be a little bit tight. So I have, what was it? 2x times natural log of 3 is equal to x times natural log of 4 plus 2 natural log of 4 plus natural log of 3 minus x times natural log of 4 to both sides. And again, trying to save space on this because it's going to get a little bit tight. I'm right there. This cancels with this. So now I have 2x minus x. 2x times natural log of 3 minus x times natural log of 4 is equal to ln of 4 plus ln of 3. Now, with this, we can see that this side both have an x. That means we can factor it out. So we factor that, and we have 2 ln of 3 minus ln of 4 equals 2 ln of 4 plus ln of 3. Well, this is a multiplication, and what's the opposite of multiplying? Well, dividing. So let's divide. This cancels with this guy, so I have 2 natural log of 3 natural log of 4. So therefore, x is equal to 2 natural log of 4 plus natural log of 3 over 2 times the natural log of 3 minus natural log of 4. That would be the solution for that mass. Okay. So we have on this one, let's rewrite this so it looks a little bit better. 3e to the power of x squared is equal to 600. So let's divide that by 3 to both sides. So I have that ex squared is equal to 200. Now, remember that the natural log is log base e, and we're using e. And remember that from here we can go to the base of change of base. So I have, so therefore 1. So that means that if I do this, I can send this to the front. So now I have x squared times natural log of e is equal to natural log of 200. And following all this, that means that this cancels out. So I have x squared is equal to the natural log of 200. So we need to square root this. So the square root goes away with the square. So I have that x is equal to plus or minus natural log of 200. From there, you can use a calculator, and it should approximate to plus or minus 2.302. Now, let's use a little bit of application for this. So, this example says the number of non-farm jobs in millions added to the U.S. economy by quarter can be approximated by the function f of x equals 12.1 plus 2.03 ln of x, where x equals 1 corresponds to the first quarter of the year 2014. Find the first full quarter in which the number of jobs added to the economy exceeded 16 million. Okay. So we have that f of x is equal to 12.1 plus 2.03 natural log of x. This is going to be rewritten because I'm going to add exceed 16 million. So this becomes 16 equals 12.1 plus 2.03 ln of x. Now we need to solve for x. So minus 12.1 minus 12.1. These cancels. And 16 minus 12.1 is 3.9 plus, equals 2.03 times the natural log of x. These two are multiplying, so let's divide now. What I do to one side, I must do to the other. Okay. So now I have 3.9 over 2.03 is equal to the natural log of x. I'm going to rewrite this, so I'm just going to flip it around so it looks a little bit better. So ln of x is equal to 3.9, 2.03. Now, a minute ago, in the previous example, we used natural log to get rid of e. So we can do the same thing. We can use e to get rid of natural log. So let's add an e to both sides. So that means that this goes away with this, leaving me with x equals e 3.9 over 2. So there's our calculator. We have second e, open parentheses, 3.9 divided by 2.03, close that. And we get 6.82, correct? Now, this was first quarter, so we're dealing with quarters. So let's round this to 7, which makes, it would take 7 quarters of the year. Of a year for this to happen. Thank you.